Hey, good morning, everybody. Today I'm bringing you a video that is focused on math and Path of Exile. And I chose a few different situations in Path of Exile where I think it is very useful to know the math behind it. And also, in some cases, it seems that people have sort of a misunderstanding of how it works. And I just want to clear that up, but then also give you the tools to do some kind of rough calculations in your head or quick calculator math if it proves useful to you. Normally, I kind of avoid focusing a lot on mathematics in my videos, and I'll reserve that for clarifying a point, but I focus on the concepts and then just, showcase breakpoints or examples or things like that that, again, help to clarify the overall understanding. Rather, in this case, I think actually knowing the math directly will be really useful. And some people in the comments in my other videos have mentioned that they would actually like a little more of a direct dive into the math behind some of these ideas. So this might not be for everybody, but there's definitely a contingent of viewers out there who will find this more interesting. So let's jump into it. So the topics I chose are how to figure out what the damage multiplier is from critical strikes, dealing damage against enemies on low life. This is a modifier that finding more and more in the game, and this one I chose in particular because of how often it seems misunderstood how this works. The damage from multiplier from critical strikes is kind of more ubiquitous. Like, so many people will play a build that uses critical strikes at some point, or even a build that uses some other chance-based damage modifier, right? Like chance to deal double damage, that it's worth touching on, even if there aren't necessarily a lot of misconceptions out there. But it's just so common that I think understanding the math will be useful. But the second one, it's actually more about there being kind of misinformation out there that I would like to help correct. And then the last one is another situation where it's actually a combination of both of these things, where a lot of people seem to have a poor understanding of this and relay misinformation related to calculating your probability of succeeding at something after a certain number of attempts. But also, it's so common in this game, and we'll go through some examples where you encounter this kind of probabilistic situation when you play PoE. So let's jump into it with crits. These couple of things on the first page here are specific to critical strikes and don't apply to other chance-based damage bonuses like chance to deal double damage, but I still think worth touching on. So chance to hit is really simple to calculate. The effectiveness modifier to your critical chance based on chance to hit is pretty easy to calculate. For those of you who don't know this, when you are factoring in critical strikes, your chance to hit roll is rolled twice. Once to see whether or not you hit the enemy at all, whether they evade your hit, and then if you then roll a successful crit roll, you actually also have to succeed in rolling a second chance to hit roll, or the crit will fail, even if the chance to crit succeeded. The chance to hit second roll will cancel it out. And so when I say effective crit chance, what I'm saying is the crit chance on your character sheet doesn't change, but the actual odds of you successfully critting an enemy do change. So very simply, you take your chance to hit and multiply it by crit chance. So if you had 100% crit chance, but only a 70% chance to hit, it's like having 70% crit chance, on top of the penalty of already missing 30% of your hits. Then there's lucky critical strikes. So for those of you who don't know what a lucky roll is in this game, lucky just means you roll twice and the better outcome is chosen. So in the case of lucky critical strikes, if you get two chances to roll a crit, only one of them needs to succeed, and then it's a crit. Right, so it's like getting two coin flips to get a heads or a tails, instead of just one. And so the way the math works there is The second roll only matters if the first roll fails, right? So let's imagine a scenario where you have 70% critical strike chance. That means 70% of the time roll 1 succeeds. So you don't care what roll 2 is, because it doesn't matter. Whether it succeeds or fails, you're still going to crit them. So then you figure out what the chance of failure is, which is this 1 minus critical strike chance part, right? So 70% chance to succeed on roll 1 means a 30% chance to fail on roll 2, and that's when roll 2 matters. So 30% of the time, you're going to roll that 70% a second time, and technically you always roll them twice, but again, 30% of the time that second roll matters, and you have a 70% chance to succeed there. So you're simply taking the 30% and multiplying it by 70%, right? The chance of failure multiplied by the chance of success, which is 21%, and then you add that back to the original crit chance. So if you have 70% crit chance, but you have lucky critical strikes, your effective crit chance is 91%, assuming 100% chance to hit. So with those things out of the way, how do you actually calculate what the damage bonus is that you're getting from critical strike chance and multiplier? So the first thing you do, very simply, or I should say the math really all happens on one line of calculation, which is that you take your bonus critical strike multiplier, right? So whatever it says on your character sheet, plus conditional bonuses, minus 100%. So let's pretend your character has 400 crit multi. Then the bonus when you crit is 300%. You multiply that by whatever your effective crit chance is. And then you add 100 back on top of that, and that's your damage multiplier, right? 100% on top of that. So just to give you an example here. So we have a character that has 60% crit chance, 95% chance to hit. And so the effective critical strike chance is just those two numbers multiplied, 0.6 by 0.95, as shown right here, which is 0.57. You then take that, plug it here in this equation, multiply it by the crit multi, which is 350% in this case, minus 1, because again, we're just extracting the bonus damage. So if you have a 350% crit multi, that means you do 250% more damage when you crit. So that converted to a decimal is 2.5 times 0.57. Take that value and add 1 to it, and the outcome is 2.42. This is the same as saying 142% more damage. Again, you always have to subtract sort of the 100% out to figure out how much more damage you're getting, and not the damage multiplier, not to confuse the two. Right, so for a character that has these stats, your crit chance and crit multi are giving you 142% more damage. So ultimately, not a super complicated calculation. You're basically saying bonus damage times crit chance, and that's actually just the more multiplier right there. And again, this can be applied to chance to deal double damage or triple damage. Let's pretend you have a 30% chance to deal triple damage. Chance to deal triple damage is a 200% more multiplier, right? Anytime you get that triple damage roll. So you just take 200 and multiply it by 30%. So that's 60% more damage, right? AKA damage times 1.6. So 200 times 0.3. And then plus this 1 on top. Okay, on to the next one. Damage against low life enemies. So just to clarify, for those of you who are unaware, there was a change a few patches ago where low life was changed to mean 50% of maximum life or less. It used to mean, I think, 35% or less, but now it means 50% maximum life or less. So many people think that what that means is whatever the more multiplier is that's being applied to your damage is kind of cut in half effectively, right? So if, let's say you had a modifier that says you deal 100% more damage against enemies on low life, people think that means you're just dealing 50% more damage, which is incorrect. It's quite a bit less than that. So just a quick couple of sort of hypothetical things to think about to showcase why this doesn't make sense if you think a little more deeply. Imagine a hypothetical situation where you had a character that had a 1,000,000% more damage when the enemy's on low life. You don't actually deal 500,000% more damage, which is half of that, right? If you took a character, let's say, that had 100,000 DPS, which is pretty low, and you gave them 500,000% more damage, they would instantly melt anything in the game. But keep in mind, in a situation where this crazy damage modifier is only kicking in when they're on low life, what that means is for the first half of their life, you're still dealing 100,000 damage a second. And then it's not till the second half that they deal that crazy damage. So you could see how that doesn't average out to something this high, right? Because that first half is going to be really slow, even though the second half is going to instantly delete the enemy in this hypothetical situation. Another way to think about it, if that doesn't kind of conceptually show you why this makes no sense, is the theoretical maximum sort of damage you could deal against enemies on low life is if you had a mod that just said culling strike against enemies on low life, right? They instantly die if they're brought below low life. Well, what that does is it doubles your damage, right? If you cut the enemy's life in half, which is what culling strike against low life enemies does, it's the same as doubling your damage, right? Them having half life is the same as doubling your damage. And so this is kind of like saying infinite damage against enemies on low life, but you don't do half of infinite more damage, right? It doesn't work like that. So these examples, again, were just to kind of showcase to you, if you think about it a little more deeply, how you can identify that this statement, or this idea that the modifier is just at half effectiveness, doesn't work. It doesn't pan out. And the reason why is this down here. More damage against low life enemies means they spend less time at low life, right? Because under normal circumstances, when you deal the same amount of damage to them while they're on, we'll just call it high life, and the same amount of damage on low life, they spend 50% of their existence in each one. But if you deal more damage to an enemy on low life, this part shrinks down and shrinks down and shrinks down. And the more you're dealing, the tinier it gets. And so the less and less time they're spending there, and so the less sort of time you get that bonus. So there's this sort of situation of diminishing returns, where the more damage against enemies on low life you get, the less it effectively boosts your DPS. Okay, so let's go into the math. So I think the easiest way to do this is to change the calculation to figure out the time that the enemy spends alive, and then sort of convert it back to damage. And so, as I said, and you can obviously understand, by default, 50% of time is spent in the low life condition. So the first thing you need to do is figure out what is the adjusted time in low life position. So you take that 50%, you divide it by the damage multiplier against low life enemies. So like, for example, if you were dealing 50% more damage against enemies on low life, that would be 1.5, right? The 150% is the damage multiplier. That converted to a decimal is 1.5. This converted to a decimal is 0.5. So you'd be dividing 0.5 by 1.5 in a situation where you deal 50% more damage against enemies on low life. Then your total time to kill is equal to the time in high life, right, which is 50%, plus the adjusted time in low life, which is whatever you figured out in this first step. And then the damage multiplier is simply taking 100% and then dividing it by this kind of modified time to kill. And so the example I'm going to give you here is using level 20 behead support, because this is one I've seen people try to convert to a more multiplier and state incorrectly that it's giving you half this value, right? They say it's going to give you 24.5% more damage against low life enemies. This is incorrect. So The adjusted time in low life is, you take 0.5, divide it by 1.49, and you get 33.6, or excuse me, 0.336. The total time to kill, I know that this isn't in seconds, but proportionally this still makes sense. So, however many seconds, like if the person was alive, 50 seconds in the high life condition, then you could convert this by multiplying by 100. Then that would mean in the situation we're describing, in the low life condition, they'd only be alive 33.6 seconds. Anyway, proportionally it works out, is what I'm saying. So you just add this number to the 0.5, and you get 0.836, right? So kind of what this number is telling you here is that if originally the time to kill, you imagined it as being 100%, then now it takes 83.6% of the original time to kill, right? That's what this is saying here, if kind of conceptually the other stuff I said didn't make sense. So then you simply divide 1 by that number, right? You're dividing the original time to kill by this modified one, and the value you get is 1.196, aka 19.6% more damage is how much you get from a level 20 behead support. Just practically speaking, in game, there's some other advantages to dealing additional damage to enemies on low life. Bosses tend to get harder, like their phases are more difficult when they're in the low life condition. Some enemies only partially heal between different phases or something like that, so they actually spend more time in the low life condition than they do, right? Then like these numbers kind of don't work out because they spend 60% of their time in the low life condition as opposed to 50% by default or something like that. So there's some other advantages to this, but just broadly speaking, this is the more modifier you get from a level 20 behead support. Okay, so finally on to the last one here. So this is the probability of getting at least one success in X number of attempts at something. So this kind of math is used in a wide variety of situations, right? If you're linking an item and you say, I have this chance of 6 linking an item, and I have this many fusings. What are the odds that I successfully 6 link if I throw all my fusings at this item? Crafting mods. What if I, roll alterations until I get a particular mod or something like that? I want to exalt slam this item, and I have the ability to scour all the suffixes and do it again. What are the odds that I get this one particular mod? Something like that. Let's say you have X number of some unique item or whatever item in a certain slot where you want a certain corruption. You have gloves you want to get +1 frenzy charges on or something like that. How many gloves is it going to take? Or if I have this many gloves to throw at the corruption chamber, what are the odds that I successfully get +1 frenzy charge on one of those gloves? Boss drops with known odds. If I, farm this boss 50 times, what are the odds that I successfully drop, a Starforge or whatever item it is that you care about at least once, et cetera, et cetera. You can see there's a lot of situations where this comes up. So in a lot of cases, just quickly, I think without much analysis, people seem to think it's just a simple addition of odds. So, if you have 1,000, let's say 1 in 1,000 chance of 6 linking an item, and I know it's a little different than that, and they say, I have 100 fusing, so I have a 10% chance, right? Because it's 100 out of 1,000. Well, intuitively, if you think about it a little bit more than that, I can see how you jump to that conclusion really quickly, but if you take that a little further and say, well, if you have 1,000 fusings, does it then guarantee 100% that you 6 link? Anybody who's 6 linked enough items knows that's not true. So it's not a simple addition of odds. And the other thing is, a lot of people actually know how to calculate the odds of multiple successes of something with known odds happening consecutively, right? So if you have, let's say, a 50% chance of something happening, a coin flip, and you say, what are the odds I get heads 3 times in a row? Well, it's 0.5 to the third power, 0.5 times 0.5 times 0.5. And a lot of people know how to do that math. So the easiest way to do this is to actually flip it and then calculate the odds of failing X number of times in a row and then subtracting that from 1. Right? So we're just reversing the problem. So first thing you do is you calculate the odds of failure instead of success. You put those odds to an exponent equal to the number of trials. Right? So like in the coin flip example, I said you take 0.5 to the third power to see what the odds are of flipping heads 3 times in a row. Well, if you wanted to see the odds of flipping heads 100 times in a row, it would be 0.5 to the 100th power. So you're doing the same thing here, but just using the odds of failure instead of the odds of success. And then you subtract that 1 to convert back to the odds of success. Now keep in mind, this is at least 1 success. Technically speaking, this calculates the odds of all possibilities except 100% failure, right? And so some of those chances are going to be incredibly low. Like, for example, if you were taking something that was a 1 in 100 chance and you wanted to know what the odds were of, in 100 trials, what the odds are of succeeding at least once, technically, you're actually calculating, the odds of succeeding once, twice, 3 times, 4 times, 5 times, all the way up to succeeding 100 times. And then all those get added together, and then that's the sum total of your odds of succeeding at least once. Now you can imagine succeeding a 1 in 100 times in a row. That number is so incredibly small as to be insignificant. But I just wanted to point out for sort of a more full understanding, that we're not talking about 1 success, we're talking about at least 1 success. Okay, so this is sort of the mathematical formula that represent the steps up here. So your chance of failure is equals to 1 minus your chance of success, right? So if you have a 60% chance of success, your chance of failure is 40%. 1 minus 0.6 is 0.4. The chance of failure X times in a row, is equal to your chance of failure to the exponent that is the number of attempts. And then once you get that number, you just subtract that from 1 to convert back to your chance of at least 1 success. So chance of at least 1 success after X attempts is 1 minus whatever you came up with in this equation above it. So let's give an example. Chance of 6 link an item after 1500 fusings. We're going to assume the odds to be 1 in 1,000, just because the numbers are a little cleaner. Chance of 6 link, I know it's something more like 1 in 1,200, but let's pretend we have an item with, 30% quality from betrayal or whatever. And we're just going to pretend that that's a 1 in 1,000 chance to 6 link. So your chance of failure, right, is 1 minus 0.001. 0.001 is a 1 in 1,000 chance, right? It's it's 0.1%. So your chance of failure is 99.9% on any given trial with these assumed odds. So what's the chance of failure 1,500 times in a row? Well, you take this, 0.999, your chance of failure, and you multiply that by itself 1,500 times, aka put it to an exponent of 1,500. Throw that in a calculator and you'll see that that is 0.223, aka 22.3% of the time you throw 1,500 fusings at an item, you will not 6-link it, if we assume 1 in 1,000 odds. Chance of at least 1 success after 1,500 attempts then is just 1 minus that chance of failure, right? So 77.7% of the time, if you throw 1,500 fusings at an item that has a 1 in 1,000% chance to 6-link, you'll get at least 1 6-link out of it. At least 1. But that's a pretty decent chance of failure still. So, sort of a shortcut here. There is some more depth you can look to outside of the scope of this, that's outside of the scope of this presentation. I don't want to go into it too much, but just a quick explanation of if you wanted to calculate the odds specifically of succeeding once or succeeding twice, basically you take the chance of each possibility multiplied by one another, and then you multiply that by the possible number of combinations given your sample and the number of successes that you have. So not worth going into in detail, but I just sort of wanted to make a quick mention of it. It is possible to calculate that, but it's probably not worth understanding how to do that off the top of your head. It's going to be a lot easier to just instead use a binomial distribution calculator. So if you go to this page, you can find a great one. I've used this a bunch of times, and it'll allow more specific calculations where you can say, all right, what are the odds that I succeed once or succeed twice? And I'm actually going to pull this up just to showcase it for you a little bit. I guess I already had it open in my browser from earlier. So in the example we gave, right, the probability of success on a single trial is 0.001, right? 1 in 1,000. The number of trials was 1,500. We said we're going to throw 1,500 fusings at something, and we want to see the odds of one success. All right, so here's the number we came up with, because it's, so in this case, the big X is the actual outcome. The little x is the number you're asking about. So in this, it's saying what's the probability that the actual outcome is greater than or equal to 1. So again, at least one success. That's this number at the bottom. This is the outcome, the probability of exactly one success, right? Big X equals little x. This is the chance of, in this case, failure, right? So that the actual outcome is less than the one you're asking about, right? So in this case, the only thing less than 1 is 0. This one is less than or equal to, so this is the odds that you succeed once or none at all. And then this is the probability that you get more than one 6-link out of throwing 1,500 fusings into, obviously you can't 6-link a single item more than once, but that if you have 1,500 fusings, assuming the same odds, that you would get 2 6-links out of it, 44% of the time. All right, so this is just, wanted to show you this real quick. It's pretty useful to have, and it's real quick and easy to use. And so I just thought that was worth touching on. And so that's pretty much it. That's all the math that we're going to go into here. And hopefully some of that proves useful. I'm sure some of you, like I said, aren't going to be super into it, but I think there will be some people who find it useful. And, you know, not every video has to necessarily be for the widest audience. I wanted to throw something out there for those who were interested, and just because I find it kind of interesting to talk about, and going through it kind of actually helps me understand things better sometimes when I start playing with numbers. So with all that said, good luck with your new math tools that you can put to use, and I'll see you next league.